We currently test for 10 cannabinoids, which is the acid and the active form of THC and CBDs, THCA, CBDA, plus the decarboxylated version, CBD and delta-9 THC. We also search for the breakdown product delta-8 THC, plus minor cannabinoids, CBG, cannabigerol, cannabichromane, and CBN. And last but not least, we also recently started testing for CBDV and THCV, which have actually, specifically the THCV, has somewhat opposite medical effect than the THC. And it's actually somewhat of a stimulant and an appetite suppressant. There's still very little science on those, but we're already reporting those since some of our clients really want to know what's in their product. The CBD has become more and more popular due to its health benefits, so we quite frequently have clients come in here that have strains like Charlotte's Web, which is fairly famous due to the CNN documentary, or AC/DC or Canatonic, and they kind of expect that those strains are high CBD strains. Unfortunately, it seems to be the case that quite frequently clones or small plants are sold under wrong names, and more often than not, when we actually test the product, they turn out to be just regular THC strains and not very high in CBD. This here are liquid chromatographs. We use those primarily for testing if the potency of cannabis products and flower. How the machine works is the samples actually sit in here. They're already diluted to to a fairly high dilution, since the machine is better at detecting small amounts than large amounts. And the machine will take a small sample with this needle. This comes over and pulls a small sample out, and then we'll inject that amount into the solvent stream that the machine pumps from the top down. And then the solvent, together with the sample, gets pushed to this part here, which is known as a column. And each of the compounds takes a different amount of time to make it through the column, so they come out at the other end at different times. And then finally, at the very bottom here, is an UV detector that literally looks through the solvent stream at a very specific wavelength and then detects the cannabinoids, since they are opaque at very specific wavelength. Another thing we test here for is mold and mildew. We have actually two different methods of testing these. For a regular turnaround, we're using count plates that essentially work like Petri dishes used to. We wash the sample with a buffer and then plate a little bit of the buffer and simply wait 48 hours for the microorganisms to grow, which we can then simply color identify on these plates. For example, you can see here the small spots. We count these at the end, and from there can then calculate how much mold and mildew was actually in the plant. However, this process takes 48 hours in the incubator, and we do have some clients that like to get their results overnight. For those, we actually offer a way of DNA testing here, which is known as PCR. Let me show you that over here. So this here is our PCR equipment, a sterile hood, Magnalyzer, Magna Pure. This is actually a machine that can fully automate the process for us. And last but not least, the light cycler is actually what does the DNA analysis. The samples actually in the machine are very small. They sit in here. These little strips is actually what the machine in the end analyzes after we isolate the DNA and load it up. How PCR works, basically, I have this little card here, is we take the DNA from basically from the buffer which we wash the plant off, split it into the RNA, and then attach a primer. This primer is something that we developed specifically for yeast and mold in cannabis. And once the primer is attached, the DNA strand rebuilds itself. And this process is repeated about 50 times to get more and more DNA, so that in the end this light cycler via UV can actually detect the DNA and can quantify how much mold will grow in the sample. This is a gas chromatograph mass spectrometer, and it has a very specific sampler on it, which is known as a headspace sampler. We use this to test for residual solvents and terpenes in concentrates or flour respectively. Residual solvents is basically solvents that were used to extract concentrates. Common are alcohols or butanes or even now CO2, although CO2 is not considered a solvent in that context. And we simply test the product if all of the solvent was removed prior to the product being sold. Currently there's no legal requirement in Oregon for that, but starting April 1st there's actually fairly strict limits set in the state that what this machine is for. How it works is we place a small amount of samples in these vials, and the vial gets heated. All the solvents move into the airspace atop, or the head space, and then the machine grabs a little bit of that, runs this through the GCMS, and can then determine exactly what solvents are in the product. So this is here essentially what we look at. It's a similar chromatogram than we saw in the liquid chromatograph. The peak is a solvent, and the machine can actually auto-identify this big peak here specifically is ethanol. It's alcohol, which is commonly used for post-production of samples. That's basically how those clear concentrates are usually made. There's a post-processing step in which waxes are removed. And that can leave some alcohol behind, which is generally not dangerous, but we still want to, of course, know what level are actually in the product. What we have here is an ultra-high pressure liquid chromatograph coupled with a triple quad mass spectrometer. This is an extremely highly sensitive instrument, and we only aware of one other of these units being in the state of Oregon at OHSU. It basically combines the benefit of liquid chromatography, but by operating at extremely high pressure, it can analyze way faster than our classic systems. And the triple mass specs is essentially 3 mass spec detectors chained together, which allows it to be extremely sensitive, somewhere to around 300 times as sensitive as the single quad GCMS. And that allows us to do pesticide testing in just about 10 minutes for all the 70 pesticides required in the state of Oregon. And this is essentially the 3 mass specs chained together. And the analyte quite literally, almost at light speed, moves through here, through the vacuum, and is magnetically deflected. That way the machine can literally look on an atomic level and can identify specific ions of the compounds. The cost of this machine is somewhere in the area of $500,000, which we just recently acquired it, but it is essentially a requirement under the Oregon rules in order to reach the limit that we have to test for. Most of our equipment is quite expensive. These liquid chromatographs start at about 30 grand a piece. The gas chromatograph mass spectrometers are about 200,000 or so a piece. So there's easily $1 million of equipment sitting around here. It's just simply required. Cannabis is, from a chemist perspective, very dirty. If you compare it to water testing specifically, hence we have to have very sensitive equipment to essentially look past all the other compounds that are in cannabis and see the pesticides.